All right, so last class we were really trying to drive home your heat versus temperature and your different types of heat transfer. Really, that class is a review from stuff that should have been taught in middle school science. So you should have learned about the three different types of heat transfer: radiation, conduction, and convection. You should have also looked at heat versus temperature. Um, in regards to heat versus temperature, as a quick recap, please remember that the definition for temperature is that it is the average kinetic energy of the actual particles. So you're getting that movement captured by your thermometer, which is recording that average movement as a temperature that you read. Heat is just that: is it hot? Is it cold? Is it warm? So that's your difference between heat and temperature. As we're going to go through, I am going to introduce you to Kelvin. We're going to kind of go over a few things from last class and a few new things for today. So, getting into Kelvin, Kelvin was the type of temperature that we brought up last class. Um, all particle movement stops at 0 degree Kelvin, and scientists have not been able to actually achieve this temperature yet. At 0 degrees Celsius or 0 degree Kelvin, all particle movement stops, like 100% completely frozen, no movement whatsoever. Even the cold vacuum of space is not at 0 degree Kelvin. That tells you how cold something really is. So if we are going to convert between Kelvin and Celsius, it's actually quite simple. All you do is you have degrees in Celsius and you add 273. And then you actually have a calculation of Kelvin. So let's use 10 degrees Celsius as an example. 10 plus 273 equals 283 Kelvin. If you're wanting to convert back, all you do is you take your temperature in Kelvin and subtract 273, and then you should have your temperature in Celsius. So again, we're going to stick with the number 10 here. 10 degree Kelvin, subtract from 273, which should give you a negative 263 Celsius. So thermal energy is going to be the total of all kinetic and potential energy within particles, and that's where Kelvin really does come into play. That's where thermal energy should be measured. It should be measured in at least Kelvin or Celsius, but never in Fahrenheit. So, kind of going through your relationships, this was something that was covered last class as well. A temperature increases, so does the thermal energy. We should have seen that in our phase diagram. Gas particles occur at higher temperatures, and we know gas particles are further apart, and they're always in a speedy motion, going somewhere really quickly. But just because temperature increases does not mean that the thermal energy will be affected as well, or vice versa. Temperature won't be affected even if thermal energy is affected. So if we have temperature that stays the same, but thermal energy increases, that means that more of a substance has been added. That's kind of where, if you have a cup of coffee and a swimming pool in the middle of summer, a hot cup of coffee will have the higher temperature, but your swimming pool in the middle of summer will have more, generally speaking, heat, heat energy, because there's more substance there. All right, so we should know that heat flows from hot to cold. That should have been done back in middle school. Specific heat, this is something that is new. So please make sure you are paying attention at here. Specific heat is the amount of energy something can hold. So I'm sure by now you have been able to realize that certain objects don't heat up as quickly as others. You have aluminum, brass, iron, like all of these different elements or compounds do not hold the same amount of energy. Some metals will begin to melt at lower temperatures. And that's where specific heat comes into play. Specific heat is technically going to be defined as the amount of heat that is required to raise the temperature of 1 kilogram of a material by 1 degree, either Celsius or Kelvin, respectively. Generally, we will see our specific heat measured in joules per grams times Celsius. What we have on this slide is joules per kilograms per Celsius. And so you're going to notice that the decimal will move from time to time. So please be very careful with your units, especially on the work today. The work today is in joules per grams per Celsius. So I'm going to make sure that this is the last slide that we go over. This is technically your equation for today for all of our calorimetry problems. And that's going to be Q equals M times T times C, also known as our MCAT or Q equals MCAT formula. Q is going to be your total thermal energy. It is measured in joules. M is going to be our mass or weight of the substance. Generally, this is going to be measured in grams. And our delta T is the change in temperature, the final temperature minus the initial temperature. And of course, last, C is going to be our specific heat of a substance. So we're going to go ahead and pull up the document camera so we can kind of work out this first worksheet. I want to kind of show you guys real quick. This right here is the worksheet that we will be going over together as a review. So majority of these questions we will work out. This particular worksheet is kind of for some extra practice. You should, and I see that I included the second page, you should only really work on the first 4 problems. And actually, by the time class starts, I might have updated it. But again, for this worksheet, you should only do the first 4 problems. 5 through 7 on the back is a no-go. Don't do that. So let's go ahead. Let's close out of this. Let's bring up our document camera. And let's go ahead and write out our formula again. Q equals MC delta T. And this is where we kind of call it Q equals MCAT, because the triangle here, the delta, kind of pretends it have legs right here, and so it has an A now. So MCAT, Q equals MCAT. Just a little trick to remember. But technically, with our delta T, delta technically means change in. So if you see this triangle anywhere in regards to either math or science, triangle is delta. It means change in. It always is going to be a final minus an initial, or where you're starting. So Q is your heat. It should always be measured in joules. M is your mass. Generally keep that in grams. Temperature is going to be always in Celsius. And last but not least, you are going to have your C. This is your specific heat. And generally, we're going to try to keep that in joules per grams times Celsius. So let's go ahead and get started with our first problem. The first problem is a little bit much. We're going to have 3 different 30-gram metal samples: aluminum, brass, and lead. So we'll abbreviate them: aluminum, brass, and lead. Lead is PB on the periodic table, so that's why we have PB here. But we have three metals: aluminum, brass, and lead. They were heated up to 100 degrees Celsius, and then each was placed into a styrofoam cup that contained 60 grams of room temperature water. After the heat exchange occurred, the temperature of metal samples was about 30 degrees Celsius. So calculate the heat energy that each metal sample lost to the water. So again, heat energy, that means you are looking for Q, which is generally measured in joules. So Q is technically going to be MC times delta T. Okay, so let's go ahead. Let's start calculating this out. First up is going to be our mass. According to our problem, the mass for each of our three metals here was 30 grams. So I'm going to put 30 grams out here. Next up, we have the same temperature change for all of these. So our delta T. And we started with 100 degrees and we ended with 30. So again, this is final minus initial. So 30 minus 100. And that should be negative 70. And that's going to be the same for all of our problems here. Because look, their conditions are the exact same. So most of y'all at this point are probably kind of looking at why is this a little bit different when they're all looking at the same. Well, here's where it starts to look different. And that's going to be at our C value, our specific heat. Look at what we were given. The first metal is aluminum, right here. Specific heat is 0.903. Next up was brass. Brass has a specific heat of 0.386. And last but not least was lead. Lead has a specific heat of 0.128. So we've got our mass, temperature, specific heat. So now all that's left is to put it into the equation and calculate Q. So let's go ahead. I'm going to start writing this out in a different color. Our mass for each one is 30. Specific heat, now this will change. Remember, each different compound has its own. So for aluminum, 0.903. And brass is 0.386. And lead was 0.128. Last but not least is our change in temperature. 30 minus 100, that means we have a negative 70. And so we have set up our entire problem. So let's go ahead. Once we have our problems set up, we're going to go ahead and pull out a calculator. Some of y'all either have your calculators on Desmos, and we can be honest, most of us at home are probably going to be doing our calculations on our phone. So let's go ahead. 30 times 0.903 times a negative 70. So in order to, on your phone, remember you have this plus minus. Just type in the number, push that button, that gets you that negative value. So I can see here for my first problem, my answer is going to be a negative 1,896.3. And we're looking for Q. Again, Q is always going to have the unit of J, joules. So I'm going to pause here. Make sure you calculate our bottom two. All right, so you should have tried to calculate your bottom two. And let's go ahead. Let's calculate them out for you. Let's double check. All right, so we should have a negative 810.6. And then for our lead, we should have 30 times 0.18 times negative 268.8 joules. Okay, so we have had 3 problems right here that we have calculated out. Let's go ahead and ask these next 2 questions. 2 is asking which metal sample released the greatest amount of energy. So technically, if you look, this one right here has had the greatest amount of energy released. So that means aluminum is our metal that has released the greatest amount. Which metal sample released the least amount of heat? Well, look for the smallest number. That should be Pb, your lead. All right, so let's do one more. Let's say that we just have a single problem, one metal, one temperature, one mass, etc. So let's look at this. How much heat energy? Again, heat energy is going to be our Q. Is required to warm 275 grams of water from 76 degrees Celsius to 87 degrees Celsius. So Q is what we're looking for. So we don't know what Q is. We know the mass is always going to be in grams. So our mass is going to be 275 grams. Our temperature change is right here. So final minus initial. So change in temperature. 87 minus 76. Let's go ahead and solve that now. 87 minus 76 equals 11. So that's our total change in temperature. All right, so we're looking for Q. We have M and we have delta T. One thing we're missing is our C, our specific heat. Again, they gave you the substance. They told you that we're looking at water. That means look at the specific heat that has been given to you. Water is right here. They give you the specific heat value. They tell you specific heat is 4.18. All right, so we have our formula, Q equals MC delta T. Fill in what we have. So Q equals MC delta T. Q is what we're looking for. Mass is 275. Specific heat is 4.18. And our change in temperature is 11 degrees Celsius. And so you would simply just multiply it out. So 275 times 4.18 times 11. That should get us 12,644.5 joules. Okay. Some questions are, of course, we are using an algebraic equation. What if I have to solve for something else? What should I do? So just like with some of the other problems where you were given triangles to help solve, I'm going to give you another triangle. Q is on top, M, C, and delta T. So make sure you have a copy of this somewhere, because if you are not very good at algebraically rearranging equations, this is perfect for you. So let's say you're asked to calculate the mass. Well, you would simply cover up m here, and you would know that your mass is equal to Q divided by C times delta T. If you're looking for the change in temperature, you would cover up your delta T, and you would know that it would be equal to Q divided by M times C. So this right here is perfect for rearranging the equation. So let's work out number 5, and then we're going to kind of release you to kind of complete the others. Before I fully release you, I will give you the formula, at least, for each problem. So that way you can kind of see how we're rearranging it each time. So let's move on to question number 5. Question 5 is, a quantity of water is heated from 25 degrees Celsius to 36.4 degrees Celsius by absorbing 325 joules of heat energy. What is the mass? So kind of off to the side, identify what you have. Mass, we don't know. You know that Q is going to be equal to your joules, what you have here, so 325. You know that your temperature is going to be final minus initial, so in this case, 36.4 minus 25. And so it's always good just to kind of solve this one right off the bat, especially if you're using a phone calculator. So 36.4 minus 25 is 11.4. And last but not least, again, we're missing that C value. Well, again, they told you what substance. You're looking at water. And so, you know, your specific heat is going to be 4.18. All right. So we've identified all of our variables. Now all we need to do is rearrange the question to solve for M. So M, cover it up. You know that to solve for mass, you're going to have Q divided by C times delta T. So let's write that off to the side. And let's put in our values. So Q is 325. C is 4.18. And our temperature is 11.4. All right, so anytime you've worked on a phone calculator, it's always kind of hard to go exactly as what you see it here. You got to remember your order of operations. Please excuse my dear Aunt Sally. Multiplication comes first. So 4.18 times 11.4. So then I have 47.652. And then my division will come next. So 325 divided by 47.652. So that means my mass will be equal to 6.82 grams. All right, so let's go ahead. Let's get the equations for 6 through 7. 6, you are looking for at a 500 gram sample of an unknown metal, gives you 640 joules. Temperature is 55 degrees Celsius to 25. What is the specific heat? So that means you're looking for C. Our mass is 500 grams. Our joules is our Q, because that's our heat. So 640. And last but not least is our change in temperature. Remember, it is final minus initial. So delta T is going to be 25 minus 55. And again, simple addition and subtraction. We know that this is a negative 30 degrees Celsius. So let's go ahead. We're looking for C. I know I can rearrange it, cover up the C. I should have Q divided by M times delta T. Number 7, I can tell you the first sentence is not necessary, it's just wordy. A reaction requires 96.7 grams of phosphorus trichloride to be raised from 31.7 to 69.2. How much energy will this require given that the specific heat is this value right here? So again, they give you C, so that's 0.874. They give you a mass of 96.7. We have a change in temperature. Again, remember final minus initial. So 69.2 subtract 31.7. And that should equal 37.5 degrees Celsius. And we have Q, which is what we're looking for because it's asking for how much energy. So looking for Q, we can cover it up, and we know Q is equal to MC delta T. All right. Number 8, how many degrees? That tells you that your change in temperature is what you're looking for. Would the temperature of 450 grams of iron, so mass is 450 grams, increase if 7,600 joules, so Q is your heat, so Q is 7,600 joules of energy is applied. So we're missing one variable. We are missing C. Again, they told you that we are dealing with iron, so look over here towards the front. Iron is right here in the middle, 0.449. Grams, joules, and joules. Okay, so if you are looking for your change in temperature, simply cover up your delta T, Q divided by M times C. So this should be our equation that we're using. Last but not least, the temperature of a 55 gram, so they gave you the mass right there. Metal drops by 113. So they're telling you that it's dropping, it's not increasing. So we know that it's going to be a negative 113 because that is a change in the going down, so it's negative. So delta T equals negative 113 degrees Celsius. As it loses 3,500 joules of heat. So Q, again, as you are losing, this number should also be negative. So Q equals a negative 3,500 joules. So what is the specific heat? That's what it's looking for. Again, we've rearranged it before for C. Q equals, or C equals Q over M times delta T. So this should be our equations. This should be pretty easy. We've given the values. All you kind of have to do is plug in the numbers and calculate the answer. If you were wanting to, you can always go for the extra problems on the other worksheet. I'm talking about questions 6, 7, and 8, or 5, 6, and 7. But on the other piece of paper, the only ones you're required to do are problems 1 through 4. So if you have any questions with any of the work, please do not hesitate to ask. But other than that, please have a wonderful day.